Now see here children, now we have to prove BD square is equal to AD into DC. Okay. Now how do you solve it? Now every proof, no children, there is a technique of solving the proof. Now I'll tell you, don't share with anyone. Always know, you have to think a reverse psychology. Reverse. Now I want to prove this. BD square is equal to AD into DC. Now you might have solved in your childhood days, a puzzle where there is a cat and there is a rat, and then the cat goes to catch the rat. There is a road, and then in between those road you'll find the obstacles. Like you might have seen like this. Okay, in your notebook you might have seen there are different roads like this, and the cat will be here. Okay, so the road will block like this, and then this way you have to go on catching the road, and here will be your rat. Now you might have always experienced, what if you go from the cat, it is very difficult to come to the rat. So when you grew up, okay, you are extra smart, you went from the rat to catch the cat. Same here. Okay, always remember, BD square is equal to AD into DC I want to prove. So what you do, you write this at the end. BD square is equal to AD into DC. I want to write this. Now you think reverse. What will be my second last step? What will be my second last step? It will be BD into BD, is that clear? Will be equal to AD into DC. Followed? What will be my third last step? My third last step will be BD upon AD, okay, will be equal to DC upon BD. This is what will be my third last step. Now remember one thing, where will you get this BD, AD, DC, AB? Now we have proved that these three triangles are similar. Just check BD is where do you get BD? Now BD is here? No, you get BD here. Is that clear? BD or DB is one and the same. Where do you get AD? AD I will get here. Where will I get DC? That I will get here. Where will I get BD? That I will get here. That means this question, this ratio is telling me that don't take triangle ABC, you take triangle ADB and triangle BDC. So what I do now, if I want to prove this, what I do, I take triangle ADB. From here only I take. Triangle ADB is similar to triangle BDC. Followed? Triangle ADB is similar to. I don't require this because nothing is there in that. So ADB is similar to triangle. Now when two triangles are similar, what do you get, children? You get their sides proportional. So after this, what you do? Take AD. This is AD. This is BD. So AD upon BD I got. Then you take this one DB. Okay. DB upon DC. That is this one. And then AB upon what you'll get? BC. Now here what do you want here? You want BD and AD. Okay, that you are having here. You want DB and DC. Do you want that DB and DC? Now DB is nothing but I can write it BD and this DC. So I'll get this here. This if I change. Now this I don't want. So what I do? I take this one AD upon BD. This I'll take and then I'll convert this as BD upon DC, which is that BD upon AD is equal to DC upon BD. Now if I cross multiply this, what will I get? I'll get BD into BD. See here, this is BD into BD. Followed? And AD into DC. This is how you solve. So you go reverse. Understood? This is how you can solve this one. So it's so easy. Now in the textbook they have changed it. They have made it to QS square. Prove it equal to PS into PR. Is that clear? What they have given here? PS into SR. That is how you are doing. You can do it by this one. This is also continuation. Understood, children? This is very easy. Now see here, children. From this same similarity of right angle triangle, okay, we can prove Pythagoras theorem also. Now in this you see what I want to prove by Pythagoras theorem. AC square is equal to AB square plus BC square. Followed? Now what I do, same what we had done in the previous one. I'll take triangle ABC. See here. Triangle ABC is similar to triangle ADB. Got it? And in this, how do you take the sides proportional? I'll take this one. So what do I get? See here. AB upon AD is equal to BC upon DB is equal to AC, okay, upon AB. Got it? Now see here, I have told you who is your best friend in the examination. Your best friend is not the friend who is sitting next to you in the board exam. Your best friend is your question paper. Now in all geometry sums, if you see now, the question tells you what to do and what not to do. Now here you see what is the question. They want me to prove AC square is equal to AB square plus BC square. Got it? Now where will I get AB square? You see the first one, AB square. I will get AB if I take AB upon AD, okay, is equal to AC upon AB. The question tells me what you want. So I will get that as AB square. Now I don't want this one, okay, BC upon DB I don't want. The next step, whatever you don't want, you don't try it. And now you take AB upon AD is equal to AC upon AB. Now when I cross multiply, see here, what will I get? AB square is equal to AD into AC. Got it? This is your first. Okay, I'll write it as first statement. Understood? Now what I do? I take the second one, which is that triangle ABC is similar to triangle BDC. Is that clear? This I will take. Triangle ABC similar to triangle BDC. Now here again I will take sides as proportional. AB upon BD, okay, is equal to BC upon DC. Got it? And then you are having AC and BC. So AC upon BC. Now what do you want? The second part you see here. What do I want? I want BC square. First I wanted AB square, that I got it. Now I want BC square. Where will I get BC square? Will I get here BC? Here you see. So now AB upon BD is of no use. I will take this ratio. BC upon DC is equal to AC upon BC. Got it? This is what you will get. Now when you cross multiply, what will I get here? BC square is equal to AC into DC. Understood? This is what you will get. This is second statement. Correct? So I got BC square, I got AB square. Understood? Now what is the question telling me? Add AB square plus BC square. So what I do? Very simple. This I have taken 1, 2. So adding, okay, add 1 and 2. Okay, when I add 1 and 2, what will I get here? AB square. Understood? AB square, I'll take like this, plus BC square, okay, is equal to AD, okay, into AC. Now see on the right hand side, I'll get AD into AC plus, because adding on the left hand side, adding on the right hand side. And here what do I get? AC into DC. Understood? AC into DC. Now here you see AD into AC and AC into DC. Is there anything common? Yes. What is common? AC. So if I take AC common, no, what will I get here? AD plus DC. Yes or no? Okay. Now you got here AC and AD plus DC. Now see here in the triangle, AD plus DC is what? AD plus DC is nothing but AC. What reason I'll write? A dash D dash C. That is AC into AC will give me what? AC square. And what is this? AB square plus BC square is equal to AC square. So that you can write again, AC square is equal to AB square plus BC square. See here children, how easy it is to prove Pythagoras theorem. Now see, all these theorems, first, second and third, all are interconnected. Understood? That is how you do. Okay? Now see here children, after Pythagoras theorem, you see on page number 36, there are some solved examples. Okay? Go through it. It's very, very important because many times, again I am telling you, many times in the board examination, questions come from the solved example also. So on page number 36, 37 and 38. Okay? And now in exercise 2.1 is very easy. You have to find the Pythagorean triplet. And what is Pythagorean triplet? They will give you 3 values. You have to just check whether it will form a right angle triangle or not. So what you do? which side is bigger one. Okay, like for example, if you take what they have given here, I'll take the third sum, 5, 12 and 13. So what you do, which is the bigger number? 13. So take 13 square. Okay, 13 square, and then you take 5 and 12 square. So 5 square is how much? 25. 12 square is 144. So 25 plus 144 will give you 169. So therefore that is nothing but 13 square. So 5, 12 and 13 is a Pythagorean triplet. If you find that the bigger number square is not equal to the sum of the other two squares, okay, then it is not a right angle triangle. So you have to just check whether it is a right angle triangle or whether it is a Pythagorean triplet. Now see here children, exercise 2.1 now. Question number 9 is very important, that comes in the board examination. Okay, so like that sums comes in the board examination. Now there is one Apollonius theorem that I will explain you. Okay, so based on Apollonius theorem there is this exercise 2.2. okay, that also you have to do it. Is that here? It's very easy. Now Apollonius theorem, if you see, children, there are 3 parts they have given. First 2 parts, then the third part is what? Apollonius theorem. I'll show you a shortcut method where you can get Apollonius theorem directly. Okay, now then in problem set, you see children, problem set, there are page number, you see 45. In that, question number 7, 8, 9, 10, 11, 12, 13, 14. All these questions are very important. One question comes in the board examination. Okay, from this page. So see that you solve every sum from this page. Okay, and similarly on page number 46 also there are this sum, that is specially 16 sum, you see, that has come in the board examination. And then 17 and 18 is Apollonius theorem. Understood? Very easy.